What's up everybody? In this video, we are going to connect an LED to an Arduino. Before watching this video, you should have watched the Tinkercad overview. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup that we made in the previous video. Hover over the basic setup and click on the gear in the top right-hand corner. Select Duplicate. Click on the name of our circuit in the top left corner and change the name to LED-manual on/off. Select an LED from the components and add it to your breadboard. When placing the LED on the breadboard, remember that the terminal strips connect 5 pins together. So pins A to E are connected on one side and F to J are connected on the other side. It does not matter where you place the LED as long as each end of the LED is in a different terminal strip. To make a circuit, we want to create a closed path to allow electricity to flow from the negative terminal to the positive. To do that, we need to connect our LED to both terminals. LED stands for light emitting diode. A diode is an electronic component that only works in one direction. If you hover your mouse over the breadboard where the LED connects, you will see at one connection the word cathode and the other connection says anode. The cathode connects to the minus or ground and the anode connects to the plus or power. If you pick up an LED from your kit, you will notice that one leg is longer than the other. The longer leg is the anode. If you look closely at the edge of the LED, you will notice that there is a flat edge. The flat edge is always over the cathode. Connect the cathode to the minus or ground on your breadboard and make the wire black. Connect the anode to the plus or power on your breadboard and change the wire to red. Great! Let's test our circuit by clicking Start Simulation. Uh-oh, that's not good. You should see an indicator over the LED. If you hover over the indicator, you will see that too much current is flowing into our LED. If you were to connect an LED on the real Arduino and breadboard, the LED would turn on, but it would burn out quickly. Once the LED has burnt out, we can no longer use it. Click Stop Simulation. We need to reduce the current that is flowing through the LED. We can do this by adding a resistor to our circuit. Select the red wire and press backspace or delete on your keyboard. Select a resistor from your components. Press the R button on your keyboard to rotate the resistor and place it into your breadboard. Next, add a wire connecting your resistor to the plus or power on your breadboard. Let's test our circuit again. Click Start Simulation. Great, our LED is turning on. However, the LED looks a bit dim. Click Stop Simulation and select the resistor on your breadboard. You will notice that you can change the resistance in the input box. Enter 220 for the resistance, and in the drop-down menu, select Ohms. You will see that the color coding on the resistor has changed. All resistors are color-coded to indicate their resistance. If you click Start Simulation, the LED should be brighter. To recap, at the end of this video, you should have connected an LED to an Arduino. We have just built our first circuit. Congratulations! When you click Start Simulation, it mimics connecting the USB cord to the Arduino. Doing so powers our circuit and electrons flow from the negative to the positive terminal and turn on our LED. When you build this circuit, you can remove and insert one of the wires to open and close the circuit, which will turn on and off the LED.